Exercise 7.2 from the Calculus by S.M. Yusuf book. Find the points of inflection of each of the following curves. Problem 14 to 17. In these four problems, we need to find out the points of inflection. Let's start from question number 14. The question number 14, the y value is given as y is equals to x cube minus x over 3x square plus 1. For finding the point of inflection, we need the second derivative. You know that in the questions from 1 till question number 10, we found the critical points. How we found the critical points? We found the critical points by finding the first derivative, made it equals to 0, and we found the values of x from there. Then we put that values of x in double derivative and we observe the behavior of double derivative on these critical points. If the double derivative becomes 0 at any of the critical point, then that critical point is called the point of inflection. So it means for point of inflection, the double derivative will become equals to 0. So we need to do here what? We need to find the second derivative and we will make it equals to 0. And we will get some values out of there, put that value in the given function, and we will get the point of inflection, exact point of inflection. So starting from this question number 14, first of all, this y function given is this one. We need to find out its first derivative, that is y dash, or you can also write it like dy by dx, the first derivative. Use the quotient rule here. The square of the denominator will come as it is. The derivative of numerator, that will be equals to 3x square minus 1 minus numerator will come as it is and the derivative of denominator. Now after simplification, we will get here 3x4 plus 6x square minus 1 over 3x square plus 1 whole square. Now we need to find out the second derivative here. The second derivative will be d2y by dx square. For that purpose, the square of the denominator, you can also just simplify it, open the square term and then use the derivative, but you can also directly use its derivative. The square of the denominator, now the denominator will come as it is and the derivative of this numerator, that will be minus, now the numerator will come as it is and the derivative of denominator, that will be 2 times 3x square plus 1. Now here one bracket I am writing here. Now you need to open these all terms, simplify it. After simplification, I will get the answer here, minus 24x times x square minus 1 divided by 3x square plus 1 whole cube. Now for point of inflection, the second derivative will be equals to 0. For point of inflection, d2y by dx square will be equals to 0. So this means that minus 24x times x square minus 1 divided by 3x square plus 1 whole cube will be equals to 0. Now this denominator will be multiplied here, so we will be left with minus 24x times x square minus 1 will be equals to 0. Now you know that this term cannot be equals to 0. So this thing means x is equals to 0 or maybe x square minus 1 is equals to 0. So one point we get is x is equals to 0. And the other point we will get from here, x square is equals to 1, so x is equals to plus minus 1. So we got 3 points for x. The first point is x is equals to 0, second point is x is equals to 1, and third point is x is equals to minus 1. Use these points in this given function and get the values of y out of this given function. Our y given function is x cube minus x over 3x square plus 1. And the first point is put x is equals to 0 in equation number 1. We will get here y is equals to 0. Now put x is equals to 1 in equation number 1. We will get y is equals to 0. Now put x is equals to minus 1 in equation number 1. We will again get the y is equals to 0 here. So it means we have 3 points of inflection. Points of inflection are, the first point is 0, 0, order pair, 0, 0. Second point is 1, 0. And the third point of inflection is minus 1, 0. So what you have to do in these questions, find the first derivative, then second derivative, make the second derivative equals to 0, get the values and put these values in the given function and make order pairs. So these order pairs are your point of inflection. So this was the question number 14. Now move on to question number 15. That is x is equals to y minus 1 into y minus 2 into y minus 3. Now for finding the derivative, it will be easy if we just simplify, if we just multiply these terms, so that it will be easy to find its derivative. So x will be equals to y cube minus 6y square plus 11y minus 6 after multiplying these terms. Now we need to find out the derivative. The derivative of x will be equals to 1. Derivative of y cube will be 3y square dy by dx minus 12y dy by dx plus 11 dy by dx. Now we can take the dy by dx common from here. So we will get at the end 1 is equals to 3y square minus 12y plus 11. This one is the difficult approach. After this step, I will tell you the easier approach from which we can easily find out the point of inflections. This will be the difficult and the lengthy as well. 1 plus, but I am telling you how it will be lengthier. 1 over 3y square minus 12y plus 11 is equals to dy by dx. Now we need to find out the second derivative. If we find the second derivative out of this, it will become more complicated. So it will be easy if we just find its derivative with respect to y. Differentiating with respect to y and just skip these steps, because you know if we just follow these steps, it will be lengthier and difficult. So we will differentiate this thing with respect to y. So it will be dx over dy. This will be equals to 3y square minus 12y plus 11. Now you see it became easier. Now find the second derivative. d2x by dy square will be equals to 6y minus 12. Now for point of inflection, make this term equals to 0. For point of inflection, d2x over dy square will be equals to 0. It means 6y minus 12 will be equals to 0. So 6y is 12. So y is equals to 2. So we got 1 point. Put this point in equation number 1, the main question. Put y is equals to 2 in equation number 1. That was x is equals to y minus 1 into y minus 2 into y minus 3. So x will be equals to, if we put the value of y here, we'll get x is equals to 0. So the point of inflection is 0 and this 2. Now question number 16. Y square is equals to x times x plus 1 whole square. Take the derivative with respect to y. We will get here with respect to x, 2y dy by dx is equals to, use the product rule here, or it's up to you. You can just open the square term, simplify it and then find the derivative. I am directly finding the derivative using the product rule. I will get here 1 times x plus 1 whole square plus this x will same, and the derivative of this function will be 2 times x plus 1. So I will get here 2y dy by dx is equals to, this term after simplification open the square, we'll get here x square plus 2x plus 1, and this term will be plus 2x square plus 2x dy by dx. This is multiplied here, it will divide on the right side, and after simplifying this we'll get 3x square plus 4x plus 1 divided by 2y. Now we need to put the value of y here. After putting the value of y and simplifying it, we will get here dy by dx is equals to, we can just factorize these terms as well. If I factorize these terms, I will get here 3x plus 1 times x plus 1 and put the value of y here. Out of this, the y will be equals to under root x times x plus 1. So this will be 2 under root x times x plus 1. This x plus 1 and x plus 1 is cancelled. So dy by dx is reduced into 3x plus 1 divided by 2 times under root x. Now dy by dx will be equals to, this term can be written as 3x over 2 under root x plus 1 over 2 under root x, and after simplifying the similar variables, dy by dx will be 3 over 2 x raised to power 1 over 2 plus 1 over 2 x raised to power minus 1 over 2. Now it will be easier to take its second derivative. So its second derivative after simplification, we will get here 1 over 4 times 3x raised to power minus 1 by 2 minus x raised to power minus 3 by 2. Now for point of inflection, d2y by dx square will be equals to 0. So this means that 1 over 4 times 3x raised to power minus 1 by 2 minus x raised to power minus 3 by 2 will be equals to 0. So this term will give us 1 over 4, it is multiplying here, it will divide on the other side, so it will become 0. And this term can be written as 3 over x raised to power 1 by 2 minus, this term can be written as 1 over x into x 1 by 2 is equals to 0. So from here we can take the common as 1 over x raised to power 1 by 2, and inside it will be 3 minus 1 over x is equals to 0. Now this shows that this term, this is it is in division, it will be multiplied, it will become 0. So we got 3 minus 1 over x is equals to 0. So 3 is equals to 1 over x, so x is equals to 1 over 3. We got a point x. Now put this point x is equals to 1 over 3 in this given equation. We will get here, put x is equals to 1 over 3 in y square is equals to x into x plus 1 whole square. We will get here y square is equals to 1 over 3 into 4 over 3 whole square. So y will be equals to plus minus 4 over 3 under root 3. So it means the point of inflection is, what was our x value? X value was 1 over 3 and y value is plus minus 4 over 3 into under root 3. So this is our point of inflection for question number 16. Now move on to the question number 17, that is a square y square is equals to x square times a square minus x square. Now find the derivative with respect to x, that will be equals to a square into 2y dy by dx. Use the product rule here. After simplification and using the product rule, we will get here 2a square x minus 4x cube. You just use the product rule and simplify it. After simplification, I have written the answer. So it will be equals to, now this thing is multiplying here, divide it on the right side. Dy by dx will be equals to 2a square x minus 4x cube divided by 2a square y. Now a square y, we need the value of y out of this function. If I get the value of y out of this, I know that y square here is equals to x square times a square minus x square over a square. So y will be equals to x times a square minus x square under root over a. Now, so put this y value here, we will get dy by dx. After putting the value and simplification, I will get dy by dx is equals to a square minus 2x square divided by a times a square minus x square. Now we need to find down the second derivative out of it. For finding that, we will get the second derivative d2 by dx square is equals to 2x cube minus 3a square x divided by a times a square minus x square raised to power 3 by 2. I will use the quotient rule here for finding this derivative, and after simplification I will get the answer for this. Now for point of inflection, d2y by dx square will be equals to 0. This means that 2x cube minus 3a square x over a time a square minus x square raised to power 3 by 2 will be equals to 0. Now this whole denominator will go here and it will become 0. So we'll get 2x cube minus 3a square x is equals to 0. Now x can be taken outside common. We will get here 2x cube 2x square minus 3a square is equals to 0. This means x is equals to 0 or this bracket is equals to 0. So one point is x is equals to 0, and from the other point this we cannot conclude the value of x out of it. So consider this point x is equals to 0 and put this x is equals to 0 in this main function. On putting it, put x is equals to 0 in equation number 1. Mark this equation as equation number 1. We will get here y is equals to 0. So this means the point of inflection is 0, 0.